Hello everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is smallest missing non-negative integer after operations. The problem category is of medium level, but we are going to solve it in a very easy way. In this problem, we are given a zero index integer array nums as an input, and there is one more input called as value, which is an integer. The problem says that there is something called as operation, and when you perform an operation, what you actually do is you can either add or you can subtract the value which is given as the input. You can add or subtract the value from any element of nums. Nums is your integer array, again given in the input. Now we know what is an operation, right? For example, if nums is 1 2 3 and the value is 2, so you can choose to subtract the value which is 2 from nums of 0 which is 1, and now your array is going to be -1 2 3, because 1 minus 2 will be -1. So 1 is going to be converted to -1. So that's the operation you can perform. Now we have to find the MEX, which is called minimum excluded of an array, which is the smallest missing non-negative integer in the array. We have to find what's the minimum excluded, or what's the smallest missing non-negative integer in the array. For example, the MEX of this array is going to be 0, while the MEX of 1, 0, 3 array is going to be 2. How? See, the thing is, in this array, what is the smallest known integer you know which is non-negative? It is 0, right? 0 is non-negative. 0 is the smallest integer, and 0 is not present in this array. 0 is missing in this array, right? Now talking about this array, in this array there are 3 elements, 1, 0 and 3. What's the smallest missing non-negative integer? Is it 0? No, we have a 0, right? First of all, the smallest integer which is non-negative is 0, right? We have a 0, we have a 1, we do not have a 2, so 2 is the smallest missing integer in this particular array. So that's what you need to return, the maximum value of MEX which is possible in the nums array after applying the mentioned operation any number of times. So we have to find what's the maximum possible value of MEX in our given array. So let us try to understand the problem using the example number 1, in which the numbers are 1, -10, 7, 13, 6 and 8, and the value is 5. It means you can either add or subtract 5 from any element, and you can perform the operation any number of times. Your only goal is to find out what's the maximum value of MEX possible in this array. Right now, if I see this particular array, the MEX is 0, right? We do not have a 0. 0 is the smallest non-negative integer, so 0 can be the answer for this particular array, right? But what we can do is we can actually add 5. We can perform an operation. We can add this element 5 in the second element -10 2 times. We can perform the operation any number of times, right? So we can add 5 in this -10 2 times, and this will become 0, right? So now our array has a 0, right? So we have a 0, and then we have other elements as 1, 7, 13, 6 and 8, right? So this is our array. So now the answer looks to be 2, because in this array 2 is missing, which is the smallest non-negative integer. Because we have a 0, we have a 1, we do not have a 2. But we can convert this number 7 to 2 by subtracting the value which is 5 from 7. So this will become 2. So we have a 2 as well, right? So we have a 0, we have a 1, we have a 2. Now the answer looks to be 2, but what we can do is we can actually convert this 13 to 3. You just need to perform the operation 2 times. You need to subtract the number 5 from 13 2 times, and this will become from 13 to 3. So now the array is 1 0 2 3 6 8. Now the answer looks to be 4. You cannot convert any of these number to 4 by performing the operation. So your MEX of nums, this particular array, is 4. The maximum value of MEX is 4. So that's how you are going to solve the problem. But what is the logic behind this? See, there is a simple logic here. You just need to find out what is the minimum non-negative integer. It is 0, right? Now you have to check that, can you have a 0 in this array? Can you convert any of this number to 0? And if you can convert that number to 0, then 0 cannot be your answer. Then we are going to move to the next number, which is 1. Can 1 be the answer? If you cannot convert any of this number to 1, then 1 can be the answer, right? So that is what we are going to do. So first of all, we are just going to pre-process our data to find out what are the different possibilities of number which can be created by performing the operation in this array. And then we are going to just loop in our data. We have a data which will start from 0, right? Our answer, the minimum answer can be 0. So we are going to start from 0, and then we will say, okay, can 0 be the answer? Can 1 be the answer? Can 2 be the answer? Can 3 be the answer? We are just going to move forward and find out what's the actual answer. And let me show you how you can find it. So the thing is, this is your given array, right? Your given array is 1, 10, -10, not 10, 7, 13, 6 and 8. Now the thing is, guys, this 1 can be converted to 1 or 6. It is originally 1. You can add 5 into this. 5 is the value we have. You can add 5 into this, and this can be 6. this can be 11 if you perform the operation 2 times, this can be 16 as well. Now there is one more operation which you can perform. Right now I am just adding the number 5. We can also subtract the number 5. But the thing is, our goal is to find the smallest positive number. We don't need to care about the negative number. So simply what we can do is, for every number from 1 to 8, we just need to find out what are the different possibilities of number this 1 can be converted to, which is positive. Don't worry about the negatives. So this 1 can actually be 1, then 6, then 11, then 16, right? Minus 10, what's the smallest positive number this minus 10 can be converted to? It is 0, right? You can perform the operation 2 times. You will add 5 2 times in minus 10 and this will be 0. But if you perform the operation 3 times, this will be 5. If you perform the operation 4 times, this will be 10, then 15. Similarly, 7 can be converted to 2. Here you are subtracting the number 5. You are performing the subtract operation. But you are keeping the number, the lowest possible number, as a positive number only. Because we want to find out what are all the different possibilities we have, and then we are going to find out what's the smallest non-negative integer in this particular data. Basically, our goal is to find the maximum value of MEX. So we are going to remove all the possibilities and then we are going to see what's the maximum value we can reach. Now, one of the logic to find out this particular data is, first of all, try to understand this data. So for 7, we can convert 7 to 2, 7, 12, 17. We can go ahead and write it as 22, or we can say 27. We can go ahead. But this is just the pattern I'm telling you what this particular data can be converted to. So we have a 13. This can start with 3, right? We can just reduce 5 from 13 2 times and this will be 3, or reduce 5 from 13 1 times, this will be 8, or this can remain at 13, or it can be converted to 18. So these are the possibilities we have. I am just writing the smallest number here. First of all, the first row is the smallest number which can be converted, like which we can convert our original number to. We can convert our 1 to 1, minus 2 to minus 10 to 0, 7 to 2, 13 to 3, 6 to 1. We can start with 1, then it can be 6 or 11 or 16. 8 can be converted to 3, can be 8, can be 13, can be 18. But how is this going to help us solve the problem? The output in this case is actually 4, right? But what's the logic to find out this output? It's very simple, guys. If you have this particular data, then concentrate on the first row. Don't worry about the other data. Let me just ignore the other data, right? Just focus on the first row. Let me highlight this first row actually. So now if you just focus on the first row only, what you need to understand is, I need to find out the MEX, right? The MEX can start with 0. First of all, I will just check, do I have a 0 in this particular data? I do have a 0, right? Here is the 0. It is a fact that if there is a 0, then MEX of this array cannot be 0. So we are going to move ahead and we are going to say, okay, let us see if my answer can be 1. We have a 1, so my answer cannot be 1. We have a 2, so my answer cannot be 2. We have a 3, so my answer cannot be 3. And we have a 4, no, we do not have a 4, so my answer can be 4, and that's the output we have. So that's the simple logic. And how can you find this particular value? The first row, simply take the mod of your number with value. 1 mod 5 is 1, minus 10 mod 5 is 0, 7 mod 5 is 2, 13 mod 5 is 3, 6 mod 5 is 1, and 8 mod 5 is 3. Now there is one catch which you need to understand here. Let us say you have a number 9 in your array, alright? So this 9 can actually be converted to 4. You can just reduce the number 5 from this 9 and this will be converted to 4. But the main thing to notice here is, now your answer cannot be 4 because you have a 4 here, right? It means you can get a 4 in your array, so your MEX cannot be 4. So what's your MEX? Is it 5? Yes, it can be 5, right? You cannot get a 5 from this particular array. Why cannot you get the 5? We can actually get the 5 here, right? But the thing is, this minus 10, we will convert this to 0, the smallest positive data. Because if you convert this minus 10 to 5 instead of 0, then the problem is the MEX will be 0, which is not the maximum, right? The maximum MEX can actually be 5 here. But what if you have a minus 10 here and you have one more minus 10? Or let us say you have a 5 in your array as well. Let me actually draw the 5 as well. Let's say you have a 5 as well. Now try to understand that this is very important. If you have a 5 here, then your answer cannot be a 5 as well, because you can convert the minus 10 to 0 and you can keep this 5 to 5. So you have a 0, you have a 1, you have a 2, you have a 3, you have a 4, you have a 5. Can your answer be 6? You might say yes, but I think no. Still your answer cannot be 6 because we have a number 6 which can be converted to 6. It will start with 1, it can be converted to 6. But how do you know that we need to convert the 6 to a 6 or a 11 or a 1 or a 16? The simple thing is, if you have a 1, then it will be converted to 1. Now again, if you see the 1, then it will be converted to the next number possible, the next positive number. The thing to notice here is, if you will see the patterns starting with the same number 1 and 1, it is 6, 11, 16, 6, 11, 16, right? So if you have two 1s, then you can actually create a 1 and you can create a 6 as well. So you can just take the frequency of the first row of the data. And what is the first row here? It is just a mod of all your numbers with value. And then later on you will see what is the maximum possible value which can be considered as your MEX, the missing non-negative positive, I would say 0 and positive integer. So enough of the talks. So now let us try to solve the problem. So first of all, we are going to store the first row data. We are going to find out the first row data, basically the mod values and their count. So we can say data is equal to a default dictionary. We are going to store our data in a hash map or a default dictionary in which every value is going to be defaulted to an integral value. By default, everything is going to be 0. Then we are going to run a simple loop in our data for n in nums. We can say the data of n mod value plus equal to 1. Now let's just print this data. Let's try to understand how can we solve the problem if we have this data. The simple thing is, let us see this particular scenario, this example, in which the num is 3032421104. The output in this case is expected as 10. Now, we have just calculated the mod values and their frequencies. So we have the mod of 3 2 times, mod of 0 2 times, mod of 2 2 times, mod of 4 2 times, and mod of 1 2 times. Now try to understand how can we find the solution. We need to find out the maximum value of MEX. What is MEX? The smallest positive integer, or 0. It can be 0 as well. So smallest non-negative integer. It is 0, right? But we have a 0 2 times. So we are going to utilize this 0 once, and then this will become 1. The next number we have is 1. We have a 1 here 2 times. So this will become 1 as well. Its count will become 1. Then we have a 2 2 times. It will become 1. Then we have a 3 2 times. It will become 1. Then we have a 4 2 times. It will become 1. Do we have a 5? We do not have a 5, but we have 5 mod value, which is 0. We have a 0, right? So we can convert this to 5, and we have 1 0 left. So this can be converted to 5. So 5 is also there. 6 can also be created because we have a 1 time, and it can be converted to 6. We can have a 7 from 2. We can have a 8 from 3, and we can have a 9 from 4. Can we have a 10? If you want 10, you should have a 0, right? Then you can say 0 plus 5 plus 5. Perform the operation 2 times and get the 10. But you do not have zeros left. It is already utilized. So now you can say the expected value will be 10. So that's how you can find the expected value as 10. So for this, we can simply say our starting answer is 0. And we can say while true. Just keep on running the loop because we are going to get the answer. We can say if the data of start mod value, if this particular value is more than 0, if this mod value in your data, its frequency is more than 0, just reduce its frequency. It's like we are using this particular data. So we can say data of start mod value minus equal to 1. Else you can just return the value of start, because we are saying that start is the answer we have. That's the maximum MEX we have. But we are going to increase the value of start if this is true, right? So we can simply say if we are in this particular loop, after reducing this value, increase the value of start. Let's try to say the start is the next number. Can that be the answer? Your answer will be coming from the else condition. The moment you are getting a value, a start value, and take its mod with the value, if its frequency is not more than 0, then that is your final answer, and you can just return the start, and that is going to be the complete solution for this particular problem. Submit this. This is going to pass all the different test cases you have for this particular problem, and the solution is good. The runtime is good, the memory used is good, so we have solved the problem in a very efficient way. So that's it for this video, guys. If this video has helped you to understand the problem and the solution approach, then make sure that you hit that like button. And if you have not subscribed to the channel as of now, then make sure that you do so, and I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this.